Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we will be doing a topic video on separation of variables. This is a new introduction to the special course, so I can guarantee you that the examiner is going to test this heavily, okay? If you don't want to lose any marks, make sure you watch this video. Make sure you understand the topic, the content, so that you don't, struggle in the exam and in your SAC as well. But let's get into the video. What is separation of variables? As the name implies, it is the separation of variables, or I guess you're going to be splitting variables apart from one another. So that's a sad romance story, and I'm going to be teaching you how to do that. So typically in a differential equation, you would have, your derivatives, dy dx in terms of one variable, maybe in terms of x, that's the easy one, or maybe slightly harder in terms of y, which you'll just have to flip, right? As we've learned before. But in some questions, like because we introduced this recently, you will have two variables on the one side. So dy dx is now equals to x multiplied by y, or just basically you have two variables in your differential equation. How would you go about doing that? If you go, do the traditional way, antiderive in terms of x, so which I'll do here. Let's try antiderive both sides in terms of x, right? Antiderive both sides in terms of x, because we're trying to solve for y, right? Antiderive both sides in terms of x. On the left hand side, life is good, the dx cancels out, you have a antidiff of 1, there's actually an invisible 1 here, if you didn't notice. Antiderive dxy in terms of x, and actually does not work, because on the right hand side, if you look, there are two variables you antiderive in terms of x. The y is also a variable, you cannot do that, you cannot antiderive y in terms of x, it's not possible in this course, right? So that is incorrect. So you cannot do that, but we still want to solve this, right? So what is a way of doing it? Well, this is what separation of variables is for. Literally, you're going to move one of them, you're going to split one of them from to the other side, essentially splitting them apart, okay? So I'm going to redo this question right here, but first splitting the variables. So we're going to take one of them, move it to the other side. Now to choose which one to split, it's really, about trial and error, but the general rule of thumb is whatever's on the numerator of your derivative, so in this case y, you'll split that over here, okay? So in this case, you'll move the y over. You won't move the x, you move the y over, okay? So in this case, we move the y over, we get 1 over y, because we divide both sides by y, and we have 1 over y dy dx equals 2x, okay? You can try by yourself, you can move the x over, and then you'll realize it wouldn't work, okay? And I'll show you why it doesn't work soon, very soon. Once you get in this form, we now antiderive, right? So what do we antiderive in terms of? Well, if you look at the right hand side, there's the only one variable here is x. You can only derive that in terms of x. So we're going to have to derive both sides in terms of x, or else it wouldn't work, right? Antiderive both sides in terms of x. So in that case, we get this. And then the good thing is the dx cancels out, and you antiderive both sides. You antiderive left hand side in terms of y. So there we go, antiderive right hand side in terms of x, and we can definitely do this antiderivative, right? This is in terms of y, that's also in terms of y. This is in terms of x, that's also in terms of x. So we can do that, we get log e mod of y plus c1 equals to half x squared plus c2. Now you don't really have to write the c1, c2, you can just combine them together because that's just a constant. And another constant, if you take c2 minus c1, you still get a constant, right? So essentially, you can skip that step and you can just write log e mod of y equals to half x squared plus c, because c will just be c2 minus c1, which is still a constant, right? So you can just skip the step. It's just showing you guys what actually is happening if you were to go the whole length. But there we go, okay? You can solve this by yourself, guys, but separation of variables right here, all in its glory. You just split one of the variables apart. The rule of thumb is whatever's on the numerator, you split that out over to the other side and then leave the other variable by itself. I'll show you because we have some time. I'll show you if you actually try to bring the x over, it wouldn't work. So just on the side here, quickly. If I bring the x, of course, over to the other side, I get 1 over x dy dx equals to y. Now, on the right hand side, it's y, so I antiderive both sides in terms of y, or else it wouldn't work on the right hand side. 1 over x dy dx equals to antiderivative of y in terms of y. This is fine, right hand side, everything's good, but look at the left hand side. Oh, actually, antiderive in terms of y. But if you look at the left hand side, you cannot cancel out the dx and the dy, right? So that means the left hand side does not work. And that's why you have to bring the other variable over instead of x. So you bring the y over, which is what we did here. Once again, rule of thumb, bring whatever's on the numerator over. So in this case, bring the y. And then once you do that, you antiderive in terms of the variable that's off by itself. So in this case, you antiderive in terms of x because it's by itself. So that is pretty much it, guys, that I want to talk about separation of variables. Hopefully you found this video useful, and if you did, please leave a like and a thumbs up. Aside from that, thank you for watching this short video, and I'll see you in the next video.